Hi, I am Dr. J. Suresh Goud, Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. Today, our topic is test of hypothesis for single mean. Before going to discuss this one, actually, in the previous session, we discussed test of hypothesis for large samples. Large sample means the sample size more than or equal to 30. Any sample size which is equal to 30 or greater than 30, such type of samples are known as large samples. Now we are going to discuss test of hypothesis for only large samples. In this topic, there are 4 different type of tests for large samples. First one, test of hypothesis for single mean. Second one, test of hypothesis for difference of means. Third one, test of hypothesis for single proportion. And fourth one, test of hypothesis for difference of means. I'll give you small difference out of these 4. See, single mean means here we have only one sample. Single proportion case also only one sample. Difference of means 2 samples. And difference of proportions also 2 sample case. In case the problem consists of only one sample, we can use either test of hypothesis for single mean or test of hypothesis for single proportion. That too large sample. In case if the problem consists of 2 samples, either we can use test of hypothesis for difference of means or test of hypothesis for difference of proportions. And we'll discuss later about what is single mean and what is single proportion in the next session. Similarly, we can define what is difference of means, what is difference of proportions in the next session. But blindly you remember that in case if the problem consists of only one sample, either we can use test of hypothesis for single mean or single proportion. That means test 1 or test 3. If problem consists of 2 samples, the 2 large samples, either we can use for t-test of hypothesis for difference of means or test of hypothesis for difference of proportions. Now, out of these 4 tests, first we are going to discuss about the test number 1, which is test of hypothesis for single mean. The description of test of hypothesis for single mean, in case consider a sample, large sample only of size n. That means we have chosen a sample of size n. And its mean is, sample mean is x bar. From the population where we have chosen this sample, from the population mean mu and its standard deviation sigma. And its standard deviation sigma. That means here in this description, we have, if you observe, we have only one sample. Only one sample. It has mean x bar and this sample came from the population with the mean mu and standard deviation sigma. Then the test statistic Z in step 4 formula is x bar minus mu by sigma by root n. In test of hypothesis procedure, we have 5 steps. In step 4, the test statistic Z equal to x bar minus mu by sigma by root n. Sometimes he may not give this value. In that case, you can take standard deviation of the sample S also we can consider. And confidence interval for this single mean is x bar plus or minus z alpha into sigma by root n. This is a confidence interval for single mean formula, x bar minus z alpha into sigma by root n or x bar plus z alpha into sigma by root n. That is the interval. Now, this is the first problem in test of hypothesis for single mean. The description of the problem. A sample of 400 items whose standard deviation is 10. See, according to the description of the problem, first we need to write what values are given in the problem. A sample of 400 items. One sample is there, that size is 400. First we need to define which is large sample or small sample. The sample size is more than 30 or equal to 30. That's why it is called large sample. Whose standard deviation is 10? Which one standard deviation? Sample standard deviation is 10. Sample standard deviation symbol S, which is 10. This sample we have chosen from the population. The mean of the sample is mean of the sample x bar equal to how much? 40. X bar equal to 40. The question is test. We are going to test whether the sample, which sample? This sample data. Whether the sample came from the population. From where? Which population? With the mean. Mu equal to 38. Mean of the population is mu. At level of significance alpha equal to 0.05. We are going to test whether this sample came from this population or not, our question. According to the statement or description of the problem, which test is suitable for this problem? In examination point of view, they are not going to mention by using test of hypothesis for single mean, by using test of hypothesis for difference of means. According to the description of the problem only, we should identify which test is suitable for the given problem. See, according to the values of this one, we have only one sample, that too large sample. That's why test of hypothesis for large sample. Here also we have 4 tests. Which test is suitable for the out of 4 tests? We can identify. We are going to verify whether the sample came from the population with the mean. We are going to test of hypothesis for mean only, that too single mean, because we have only one sample. That's why this problem is suitable for the test of hypothesis for single mean. Like that, we should identify which test is suitable for the given problem. Now, all the 5 steps. Step 1, we are going to set up null hypothesis, which is H0. We have to define mu equal to 38. Means this one is a population mean. That means mu equal to 38 means whatever the statement is given S, the sample came from this population with the mean mu equal to 38. And alternative hypothesis, which is defined as H1, this is against null hypothesis. No, the sample doesn't come from the given population, that is mu not equal to 38. See, this mu equal to something is fixed for test of hypothesis for single mean. And level of significance alpha 0.05. Z alpha value we have to choose at alpha equal to 0.05. See, in alternative hypothesis, mu not equal to 38 means, which is called as two-tail test, because it is not greater than 38 or not less than 38. Mu not equal to 38, where not equal to 38 means which is two-tail test. So now we are going to choose Z alpha value at alpha equal to 0.05, a two-tail test from Z distribution table. I will show you now how to choose Z alpha value from Z distribution table at alpha equal to 0.05 for two-tail test. This is level of significance Z alpha distribution table, where alpha is 0.01, 0.05 or 0.1. That means 5% level of significance or 1% level of significance or 90% level of significance. So our value is 5% level of significance. Which type of test? Two-tail test, right-tail test or left-tail test? Our problem is two-tail test because mu not equal to 35. So Z alpha value is 1.96. Like that, by using this Z distribution table, we have to choose Z alpha value 1.96 at 5% level of significance for two-tail test. Z alpha is 1.96 at alpha equal to 0.05 because which is two-tailed test. Two-tailed test. Now, the step 4, test statistics, Z formula, Z equal to X bar minus mu by sigma by root n. But sigma value not given. Instead of sigma, we can take S, which is equal to 10 from the problem. So, X bar sample, random mean of the sample is 40, minus mean of the population is 38, by sample standard deviation is, by sample size is 400. If you simplify, we are going to get 4. So, mod Z equal to also 4. And Z alpha value in step 3, 1.96, mod Z is 4. In step 5, we are going to compare mod Z value is greater than Z alpha value. That we are going to discuss in the conclusion step 5. Mod Z is greater than Z alpha. That means we are going to reject null hypothesis. Null hypothesis rejection means H0 is mu equal to 38. The sample came from the population. This we are going to reject. That means the sample doesn't come from the given population with the mean 38. And in the problem also mentioned, we should find out confidence interval for single mean at alpha equal to 0.05. The confidence interval formula we have X bar plus or minus Z alpha into sigma by root n. All values we know that X bar 40 minus 1.96 because Z alpha 1.96, sigma is 10 by root n, comma 40 plus something. So therefore, this is the confidence interval. Confidence interval for single mean 39.02 to 40.98. Like this, we have to do the problems on test of hypothesis for single mean. One logic we should remember that according to the problem description, we should identify which test is suitable for the given problem. Blindly, you remember that if it has only one sample, and whether we are going to test mean or proportion, we should check it. If it is mean, go for test of hypothesis for single mean. If it is proportion, go to test of hypothesis for single proportion. Now we'll discuss the second problem on this topic. This is the problem. An oceanographer means he is a person to check the depth of the ocean. We can call as oceanographer. Oceanographer wants to check whether the depth of the ocean in certain region is 57.4 fathoms. This fathoms is units of the depth of the ocean. So the population mean is clearly given 57.4 fathoms as had previously recorded. What can he conclude? What he is going to conclude at level of significance alpha 0.05. Alpha 0.05. In that particular certain region, he chosen some recordings for 40 random locations. So sample size is 40, only from 40 locations in the given region. Whose mean is, which one means that 40 random locations? That means sample mean 59.1 fathoms with the standard deviation. Which one standard deviation? Sample standard deviation 5.2. What is the problem here? What can he conclude? What he is going to conclude? Here we have only one sample with the data of mean. That's why we can use test of hypothesis for single mean only. The step for null hypothesis, which is denoted by H0, mu equal to 57.4. I told you that in the previous problem, directly mu equal to something is the setup null hypothesis. And alternative hypothesis, which is against to null hypothesis, mu not equal to 57.4. Not equal to, we got it. That's why which type of test? Two-tailed test. Which is two-tailed test. And level of significance given alpha 0.05. At two-tailed test, Z alpha value 1.96 only. Seeing that value from Z alpha distribution table, Z alpha equal to 1.96. Now the test statistic formula, test of hypothesis for single mean, Z equal to x bar minus mu by sigma by root n, but sigma not given, we can replace with s. So in that case, Z equal to x bar minus mu by s by root n or sigma by root n, but sigma value not given. In that case, we can use instead of sigma, which is s, because sigma is a standard deviation of the population. If it is not available, we can use standard deviation of the sample, which is s. So x bar 59.41, mu 57.4, and standard deviation of the sample 5.2 by root n. Sample size 40. 2.06. Mod z you can take 2.06. And z alpha is 1.96. Mod z is 2.06. In step 5, conclusion, we can compare these two values. This value is greater than z alpha because 2.06 is greater than 1.96. So we reject null hypothesis according to the procedure of test of hypothesis, because greater than means reject, less than means accept. So therefore, what we are going to reject? Null hypothesis. What is null hypothesis? Mu equal to 57.4. This is we are rejecting. That means whatever the locations he has taken, that is wrong from the population. Whatever he has taken the sample of 40 random locations, which is not taken from the population with the mean mu equal to 57.4. Now the third problem, here the mean of random sample, directly sample is given. The mean of random sample, that means this is x bar. And SD, which one SD? Sample SD, S also given. If sample size is 50, N is given 50. Find 95% confidence interval. 95% confidence interval means 5% level of significance. 95% confidence interval means 5% level of significance, nothing but alpha equal to 0.05. So alpha equal to 0.05, Z alpha value 1.96, we know that. What we are going to find out? Find 95% confidence interval for the mean. So directly we have a formula, confidence interval for the single mean, x bar plus or minus Z alpha into sigma by root n. So x bar 11,795 minus Z alpha, sigma not given, s is given by root n 50. X bar plus is there 1.96, this one is also s by root 50. So this is the confidence interval. Confidence interval for single mean at 95% confidence level, nothing but 5% level of significance, because confidence level formula equal to 1 minus alpha into 100%. That means 1 minus alpha into 100%. Suppose if it is 95% confidence level, so from this 95% by 100% equal to 1 minus alpha. So 95% by 100%. So which is 0.95 equal to 1 minus alpha. Alpha equal to 1 minus 0.95. So alpha equal to 0.05. So 95% confidence level is also equal to 5% level of significance. 5% level of significance. This is level of significance. So confidence interval formula is, confidence level formula is 1 minus alpha into 100%. This is the procedure for test of hypothesis for single mean. According or based on the description of the problem, we should identify which test is suitable for the given problem. Blindly we can remember if it has only one sample, that it should be large. First case, one sample, large sample, and if we want to check whether the mean came from the population or not, we can use test of hypothesis for single mean. In case, if it has two samples, we'll discuss in the next session, but blindly you remember, it should be a one large sample. Whether the sample came from the population or not, we can use test of hypothesis for single mean. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.